You're listening to Papilio Effect. I'm your host, Jody. Welcome back to another episode where we explore the ideas that shape the way we understand ourselves and the world around us. Today's episode is called Rewriting Science. Now, that title might sound strange. Can science really be rewritten? The answer is both yes and no. Science doesn't rewrite reality. Gravity doesn't change because we discover something new. The Earth doesn't suddenly become older or younger. The universe doesn't rewrite its own rules. What changes is our understanding of reality. Science isn't a collection of permanent facts carved into stone. It's a method, a process, a way of asking questions, testing ideas, gathering evidence, and changing our minds when the evidence points somewhere new. In other words, science is designed to correct itself. And that's exactly what makes it so powerful. Imagine you're trying to solve a giant mystery with only a flashlight. At first, you can only see a small part of the room. As your flashlight gets brighter, you don't change the room. You simply see more of it. That's what science does. Every new discovery shines a little more light on reality. Sometimes that confirms what we already believed. Sometimes it forces us to rethink everything. Let's look at a few examples. For thousands of years, people believed the sun moved around the earth. It made perfect sense. Every morning the sun appeared in the east. Every evening it disappeared in the west. Without telescopes or satellites, that explanation seemed obvious. Then better observations and better mathematics showed that the Earth orbits the sun. The sky hadn't changed. Our understanding had. Here's another example. If you ask someone today what causes stomach ulcers, they'll probably say bacteria. Specifically, a bacterium called Helicobacter pylori. But for much of the 20th century, many doctors believed ulcers were mainly caused by stress, spicy food, or excess stomach acid. Then researchers gathered evidence showing that many ulcers were actually linked to bacterial infection. Medical practice changed because the evidence changed. Millions of people benefited from that correction. Think about dinosaurs. When many people picture dinosaurs, they imagine giant green reptiles dragging their tails across the ground. But that's not what many scientists believe today. Fossils discovered over the past few decades have revealed that numerous dinosaurs had feathers. Many held their tails differently than older illustrations suggested. Some moved in ways that surprised researchers. The dinosaurs didn't evolve overnight. Our picture of them became more accurate. Even our understanding of the universe continues to evolve. Scientists have discovered that most of the matter and energy in the universe appears to be something we can't directly observe. These ideas are often called dark matter and dark energy. We know something seems to be affecting galaxies and the expansion of the universe, but scientists are still investigating exactly what those phenomena are. This isn't a weakness in science. It's an honest admission that there are still questions to answer. One of the biggest misconceptions about science is that changing your mind means you were wrong. But imagine never changing your mind. Imagine refusing to update a map after discovering an entire new continent. That wouldn't make you consistent. It would make your map less useful. Science updates its map of reality whenever reliable evidence demands it. That's a strength, not a flaw. Of course, not every scientific claim turns out to be correct. Some ideas that once seemed convincing don't survive further testing. That's why scientists repeat experiments. They invite criticism. They publish methods. Other researchers try to reproduce the same results. The goal isn't to prove yourself right. The goal is to discover what's true. When an idea survives years of testing from researchers all over the world, confidence in that idea grows. When it doesn't, scientists investigate why. Sometimes they find mistakes. Sometimes they discover something even more interesting. This is why you'll occasionally hear headlines saying, "Scientists were wrong." But that's often an oversimplification. In many cases, scientists weren't throwing away everything they knew. They were refining it, adding detail, improving the picture. Knowledge rarely jumps from completely false to completely true. More often, it becomes more complete over time. There's a lesson here that applies far beyond laboratories. We all build mental models of the world. About people. About relationships. About ourselves. Sometimes those models need updating. Not because reality changed, but because we've learned something new. Being willing to revise your beliefs when the evidence changes isn't weakness. It's intellectual honesty. Science doesn't promise certainty. It promises something far more valuable. A reliable way of getting closer to the truth. That's why scientific knowledge has grown so dramatically over the last few centuries. Not because scientists never make mistakes, but because the scientific method allows those mistakes to be found and corrected. The ability to self-correct is one of science's greatest achievements. So the next time you hear that a scientific idea has changed, don't immediately assume science has failed. Instead, remember this. Science isn't a book that's finished. It's a conversation that's still unfolding. Every experiment, every observation, every telescope pointed at the sky, every fossil uncovered from the earth, every medical breakthrough, every new question. They all help humanity understand reality a little more clearly than before. And perhaps that's the most exciting part of science. Not that it has all the answers, but that it's always searching for better ones. Thank you for listening to Papilio Effect. If this episode made you look at science differently, consider sharing it with someone who loves asking big questions. Until next time, stay curious.